Welcome, functions folks. We're on lesson 1.3, which is the lesson on zeros and the factored form. We got another sort of weird setup today where we're doing a lot of learning in class, but that's okay. We'll sort this all out. So here's the sort of plan for the next um, little bit of time in functions class. The 3-minute review is this video, and hopefully you've tried it. The 3-minute review. I'm going to take this up. It shouldn't be too long, but there's some stuff we want to make sure you've got. Then we've got a couple of in-class activities, which is going to break up the videos. So this is in class. Shouldn't be too long, maybe 20 minutes or half an hour. And then there's a take-up video that will make sure you got out of the in-class activities what you were supposed to get out. And then, of course, the homework and FAQ go after that. Now, probably you'll get a chance to start one of these two things in class, whether you've got access to the videos in class or not, and depending on how well you and your partner did on the in-class activities, the homework should be pretty straightforward. So let's get into it. A quick note about turning points. So this graph has, well, 1, 2, 3 turning points. We can see probably it's a degree 4 function, 3 turning points, starts high and ends high. Normally we refer to turning points as maximums or minimums. Okay, so here point P is called a local minimum. And the idea there, a local minimum, means compared to all the points that are around it, it's the lowest. Locally, if I sort of zoom in, that point P is the lowest, and it's a turning point. Notice that overall, it's not the function's minimum because R gets lowered. In fact, there's a whole bunch of points over here that get lower than P. Point Q is called a, what did you write? A local maximum, right? Because compared to all the points that are close to it, it's the highest. Now notice point R is a local minimum because compared to all the points close by, it's the minimum, is a local minimum. But it's also the overall minimum. This is the lowest that this graph goes, is R. So it's also a global maximum. Another word for this word global might be absolute maximum. Also note, well, if I talked about R is the absolute or global not maximum, holy moly. Rough start to the day here. That's a global minimum, of course. You caught that error, right? Well, thanks for pointing it out. No, just kidding. Okay, so if it's the lowest point that the graph goes, what would be then the absolute maximum? Q? No, because we see all these points over here are higher than Q. So what's the absolute maximum? Well, there isn't one. Global maximum. Okay, and so I've probably already used these terms, local minimum, local maximum, global minimum, global maximum in class, and now we've got it into our notes, so for sure you can understand that as well. All right, that was 3-minute review part 1. 3-minute review part 2. Hopefully you've done this already, some review. How would I graph this parabola? And it's a parabola because there's 2 brackets. I know the zeros are 3 and -1. And I also know that it's a parabola from grade 10 that the axis of symmetry is right between the 2 zeros, and then I can get the x-coordinate of the vertex is the halfway point, which is 3 plus minus 1 divided by 2. You remember this from grade 10? Well, hopefully you do. And then I can get the y coordinate by substituting that in there. That being the value for x in there to get the vertex. Probably some of you could just eyeball it as well, right? Minus 2 times positive 2 is minus 4. And 1, 2, 3, minus 4. Probably you could have eyeballed it because you know that there's no stretch factor, so this is just the normal parabola over 1 up 1 over 1 up 3 over 1 up 5, and I can get it like that. Dandy. Okay, so that's some grade 10 review for us, I suppose. What allowed us to graph this, by the way, are the zeros, and that's what today's lesson is all about. So that one's done. Let's change the color. This one is just the normal parabola moved right 3. So its vertex is right here, and no stretch factor over 1 up 1. Over 1 up 3. This is grade 10 review. Also some transformation review, I suppose. What I want you to sort of have a look at here, and I should label all these, I suppose, is look at the way this purple graph behaves near x equals 3. Okay, and that's what we're going to be investigating today. All right, dandy. And that's just review, setting you up for today's investigation. Here's a cubic exponent 3. We've never done one before, so we might be tempted to go to a table of values. Just put in values for x and then cube them. -8, -1, 0, 1, and 8. This is actually now, if we can remember this is like another parent function, a basic graph. And we'll actually get some experience with that soon. But let's just plot those points. We got 0, 0, 1, and then 8. I don't know if I can fit 8 on there. 2, 4, 6, way up there. It goes up very quickly. And 2, 4, 6, way down here. Goes up very quickly. And in fact, this is going to become later a basic graph for us. Again, what I want you to notice is look at the 0 and the behavior of the graph near the 0. Okay, that little shape there. But if we think of this blue one as a basic graph, then what would this one be? This would be this moved left 2, right? In with the x, it goes the opposite direction that you think. This would be left 2. So I take all these points, move them left 2. 1 there, left 2. And down here, left 2. And then I get this graph. And again, have a look at the behavior of this green graph near its 0. And that's a hint for later today when you do the investigation. All right, dandy. All right, part 2 is kind of a review of yesterday or last class's stuff, this idea of a quick sketch of this and how accurate is your sketch. Well, what do we know? We know it's degree 4. Leading coefficient, A is -4, so these two things together tell us that it starts low, ends low, right? Because it's a even degree polynomial function. It starts and ends either high or low, and this one negative leading coefficient starts low, ends low. And if we wanted the end behaviors, we could write that if we want to. Why not? A little review. Starts low is that starts low, ends low, right? Starts, that's a minus there. Fix that up so it looks there, minus. Starts low, ends low. What else do we know? Not much. So if I were to graph this, I know maybe that it has up to 3 turning points, up to 4 zeros. But do we know any of this stuff for sure? No, not really. Certainly I could get a point real quick. If I put in x equals 0, I get a y coordinate of minus 1, so an x-intercept, or y-intercept rather, of minus 1. I don't know the rest though. Maybe I know the general shape of a degree 4 means it's an m or a w, and I know that it starts low and ends low and goes through that point, but the rest is really just guessing, right? So the green stuff I know for sure. The rest, who knows? All this dotted stuff is question marks. We don't know. So how accurate is your sketch? Not very. Well, what would be a great thing to improve the sketch? We'd like to know the zeros, right? If we could find the zeros, just like we had up here, the zeros were a big help in graphing them, right? We'd like to know the zeros, and that's actually what today's activities are about. Well, the first activity is just a little bit of a fun thing, connecting graphs and tables and equations and that sort of thing. The second thing is an investigation with technology, probably the TI-83s, but if you use Desmos online graphing calculator on your phone or iPad or whatever, you could do that too. And so this is the first activity, and this is where we'll start in class. So I'm going to stop that. You're going to do the activity in class. We'll come up with the take-up video either at the end of class or for homework later. That's it for right now.